The new treatment are humanized monoclonal antibodies. What this means is that in a mouse model, mouse are given the virus, they're given Ebola virus, and they produce an antibody response. And what scientists have done is taken the cells which produce these antibodies and altered them so that the antibodies are what we call humanized antibodies and can then be used for human treatment. What we've seen so far is that the 2 humans who've been treated with this new drug appear to be doing well. Now, the first man who was treated apparently had a miraculous response within an hour. This would be very unusual, and so it's hard to know really what to make of that. The second patient, a woman, also appears to be generally doing okay, but we're not really going to know whether this drug is effective until it can be tested properly in treatment trials where some patients get the drug and some get a placebo or get nothing.
I think that we are actually quite close to having effective immunotherapeutics. The anecdotal evidence from the patients in Atlanta is very promising. We will follow up on that, see how these drugs of this class can work in all these serious hemorrhagic fevers. In our own studies here at Tulane University, we've made antibodies directly from people. So we start out with human antibodies and turn those into monoclonal antibodies, which we think is a little bit of a step forward and probably the way of the future in terms of these immunotherapeutics. Okay. This virus that was emerged from the rainforest areas in Guinea is a little bit different virus than has occurred previously in Central Africa. It's not quite as virulent. People tend to stay healthier a little longer, and so they can spread the virus easier. And so this has created sort of a perfect storm for this outbreak. This is why it's now about 3 times larger than any outbreak that we've seen before, and it doesn't look like it's going to be brought under control anytime soon.
Sorry.
You have to close it.
Yeah, I have to turn on so it shakes.
We put them into bacteria, other vectors, things like that.